As someone who just loves diving into how things work, I feel like you, our listener, are probably incredibly used to technology feeling, well, a little bit like magic.
Oh, completely. We all are, really.
Right. Like you plug a cable into a port and a little green LED blinks to life.
You get that little pleasant chime from the speaker.
Exactly. And suddenly data is just flowing. It's totally seamless. It's expected. You connect A to B and, C just happens.
Until it doesn't.
Right. Until there's that terrifying moment when the magic suddenly and just completely catastrophically stops.
And that's exactly what we're looking at today.
Yeah. So today, for this deep dive, our source material is this highly confidential technical support memo. And we're going to deconstruct this document because it completely shatters that illusion of technological magic.
It really does. It forces us to look right under the hood of modern electronics. Because that moment when the physical reality of the objects in your hands completely betrays the expected outcome. I mean, it's jarring.
Frustrating.
Because we've spent decades being conditioned to trust the physical connection. Like, if the physical key fits in the mechanical ignition, the car engine turns over.
Right. Or if the USB cable clicks into the port, the data transfers.
Exactly.
But what happens when the physical connection is flawless, but the digital permission is violently denied?
That is the core of this whole thing.
Welcome to our latest deep dive. Today, we have this absolutely fascinating high-stakes standoff between physical hardware and digital bureaucracy.
It's a massive clash.
It is. And our mission for you today is to understand the precise anatomy of what the industry calls a software rejection.
Right.
We are going to explore how a massive financial investment can be completely paralyzed by just a few missing digits.
Which is wild to think about.
It's crazy, and we'll look at what this microscopic technical failure teaches us about the sprawling modern tech ecosystems we all basically rely on now.
Yeah, this memo serves as a perfect microscopic lens for a huge macroscopic shift in engineering. Because this is not a story about a broken wire or a blown capacitor or a shattered screen.
Right, it's not physical damage.
Exactly. This is a story about a breakdown in digital diplomacy. It is a failure of negotiation between machines that have been explicitly programmed not to trust one another.
Wow. Programmed not to trust. Let's set the scene for the listeners so you can really picture this. Our core subjects today are two pieces of highly advanced professional automotive diagnostic equipment.
Top of the line stuff.
Yeah. First, we have the ThinkTool Expert 399 tablet. So think of this as the brain.
It's the command center of a modern mechanic's garage.
Right. And its companion is a ThinkTool scope box. And the text of our source memo actually gives us the exact serial number for this scope box.
Yeah, SN 9TDPB9800298.
Which, including that serial number, really emphasizes the forensic, incredibly specific nature of the text we are analyzing.
It grounds the whole thing.
It does.
Yeah.
We aren't talking about hypotheticals here. We are talking about this specific piece of hardware failing to talk to that specific tablet.
Right, that serial number anchors the entire document in reality.
And a scope box, maybe you should explain what that actually is for context.
Oh, sure. So a scope box is essentially a highly sophisticated digital oscilloscope.
Okay.
In a modern vehicle, you have something called a CAN bus system. It stands for Controller Area Network.
Right, I've heard of that.
Yeah, it's basically the nervous system of a car. It's where all the microcontrollers and devices communicate with each other without needing a central host computer.
Okay, so it's a bunch of components talking constantly.
Exactly. And the scope box physically taps into those electrical signals. It reads these tiny microsecond fluctuations in voltage to diagnose complex engine or sensor faults.
So it's incredibly precise.
It is a precision instrument.
Yeah.
So somewhere right now, a technician is looking at that exact string of characters, 9TDPB9800298, etched right into the plastic.
Just wondering why their expensive precision equipment is completely dead. And the symptom is so dramatic. Like, the technical memo outlines an immediate crisis. You have the tablet, you have the scope box. They are connected via a physical cable.
Solid physical link.
Right. And the user taps the screen to launch the oscilloscope application on the tablet to, do their job and read those CAN bus electrical voltages.
And what happened?
The tablet flat out rejects the module. The text literally says it fails to maintain a stable connection.
Yeah.
The application immediately crashes, disconnection errors pop up everywhere. The system doesn't just glitch, it is effectively bricked.
And I want you to notice the phrasing in the memo. Rejects.
Right, rejects.
That word is doing some heavy lifting. This is a deliberate programmed refusal to cooperate.
It's not a mistake.
No, the port isn't loose. The processor isn't fried. This is a breakdown in the rules of engagement. The software is functioning exactly as it was designed to function under these specific flawed conditions.
Okay, let's unpack this because it is such a wild concept when you really stop to think about it.
It really is.
The tablet knows the scope box is plugged in. The physical electrical signals on the USB bus are saying, hey, hello, I am a ThinkTool scope box and I am drawing power from your port.
Right, the hardware sensors acknowledge it.
But the tablet is essentially pausing, picking up a digital telephone, calling a remote Thinkcar server, and waiting for an invisible nod of approval before it actually lets the user see those voltage waveforms.
Yes, that separation of physical presence from authorized utility, that is the defining characteristic of modern industrial design.
It's everywhere now.
It is. The text provides a crucial line here. It says, the tablet recognizes the hardware, but the Thinkcar server denies the software execution.
So the hardware connection is essentially meaningless on its own.
Exactly. It's no longer sufficient to grant access to the tool's capabilities.
Wait, if the server's doing all the work, what is the actual mechanism here? Like, how does a piece of plastic and silicon know to wait for a server?
Well, it really comes down to how the operating system manages external devices.
Oh.
Historically, you plug in a device, the operating system looks up a local driver file, loads it into memory.
And the device just works.
Right. But in a unified ecosystem, which this memo explicitly references, the local driver contains a conditional statement.
A conditional statement.
Yeah, it essentially says, I see the hardware, I know how to speak its language, but I am programmed to halt execution until I receive a cryptographic token from an external authority.
Wow.
A token validating this specific pairing.
So it is less like a bouncer at a nightclub just looking at a printed guest list and more like a high-level spy challenge and response countersign.
That's a great way to put it.
Right. Like the tablet has half of a physical lockbox, the scope box has the other half. They physically fit together perfectly. But inside that lockbox is a mathematical puzzle. And neither the tablet nor the scope box has the answer key.
They don't know the answer.
So they have to transmit the puzzle to a server thousands of miles away, wait for the server to solve it, and send the answer back to open the box. And if the server says no, or the server just cannot be reached because your Wi-Fi is down, the box stays locked, even though you are literally holding both halves in your hands.
That is a much more accurate visualization of the code level reality. The physical connection only establishes the pathway for the challenge and response to occur.
It's just the road.
Right. It doesn't guarantee the response will actually be validated.
I have to push back on this, though, because let's look at this from the perspective of the actual user, Mr. Evgeny, who the memo mentions by name.
Right. The guy actually trying to do the work.
Yeah. If I am holding a tablet in my left hand and a diagnostic box in my right hand, and I connect them with a cable in my own private garage, why on earth does a local physical connection between two tools require a remote server to handshake them?
It seems counterintuitive.
It totally does. If they are physically connected, shouldn't they just work? Why introduce this massive point of failure?
You would certainly think so.
Yes.
Especially given the history of mechanical tools. I mean, a wrench doesn't check a server before it turns a bolt.
Exactly. A wrench is just a wrench.
But we are looking at the evolution of hardware into what the industry calls software as a service.
SaaS.
Yes, SaaS applied to physical goods. From the manufacturer's perspective, in this case, Thinkcar, they are managing a vast ecosystem.
Right.
By requiring that remote server validation, they enforce a really strict environment.
So it's about control.
Total control. They can push immediate security updates. They can instantly disable stolen equipment.
Oh, that's true.
And crucially, they can strictly enforce licensing agreements.
Yeah. And there it is.
Yeah.
It's the exact same debate we've seen playing out across multiple industries over the last, decade?
Easily a decade, yeah.
We saw it with John Deere tractors, right? Where farmers couldn't physically repair their own engine parts.
Because the onboard computer required a proprietary software handshake to recognize the new mechanical part.
Yes. And we see it with Tesla, where battery capacity or heated seats are physically installed in the car you bought.
But they're digitally locked behind a software paywall.
Exactly. The physical hardware is just a dormant host body until the software breathes life into it.
The broader industrial shift is moving entirely away from selling a product to selling access to an ecosystem.
Access, right.
The tablet and the Scotox are not two independent tools choosing to collaborate.
What are they then?
They are two subordinate nodes in a network basically asking their mutual central authority for permission to speak to one another.
That is so dystopian when you phrase it like that.
But it's true. And when that permission is denied, we get what the text calls a license pairing conflict.
And a license pairing conflict is what takes down the whole ship.
Exactly.
So, having established that the server is the ultimate authority rejecting this connection, let's zoom in on the exact anatomy of that rejection.
Let's do it.
Because the document states that the devices are not properly handshaked under a single user account. How exactly does this failure happen at the code level?
So in digital architecture, a handshake is a foundational cryptographic concept. It is a mutual authentication process. Device A sends a cryptographic challenge, like a really complex string of data, to device B.
Right.
The device B uses a specific mathematical formula to solve it and sends a response back. If both provide the correct mathematical answers, they establish trust.
They agree that they are who they say they are.
Yes, they agree on a cipher, and they begin securely sharing data.
But here, the handshake is failing.
Miserably.
And the language the text uses to describe the aftermath of this failed handshake is really striking. The text states that without this proper authentication, the software treats the scope box as an unauthorized or foreign device.
Foreign device.
Yeah. Here's where it gets really interesting to me. We are applying geopolitical language to a plastic box with some circuit boards in it.
It's true.
The tablet is looking at the scope box, its own literal brand companion, manufactured in the exact same factory.
By the same company.
And it's treating it like a hostile intruder.
Well, this illustrates a really critical engineering philosophy. It's the concept of fail deadly versus fail safe.
Fail deadly. That sounds intense.
It is. In a fail safe system, if a minor component breaks, the system degrades gracefully.
Like maybe you lose some advanced features, but the core functionality remains.
Exactly. The system fails into a safe operational state. But this ecosystem is programmed with a fail deadly philosophy regarding licensing.
Hold on, let me stop you right there. Why would any engineer intentionally design a tool to fail completely and abruptly?
It seems counterproductive.
It seems like terrible design, especially if the goal is to, fix cars.
Right. From a user utility standpoint, it is incredibly frustrating.
Yeah.
But from an ecosystem integrity standpoint, it is considered absolutely essential.
Okay, how so?
Consider the stakes of automotive diagnostics. If a compromised, unauthorized, or improperly calibrated tool is allowed to interface with a vehicle's braking system, the ABS.
Oh, wow. Okay, I see where you're going.
Yeah, and it misdiagnoses a fault, or worse, writes corrupted data to the car's computer, the safety implications are catastrophic.
Right. You could literally cause a brake failure.
Exactly. By treating an unpaired device as foreign and immediately crashing the application, the system prevents unverified data from ever entering the diagnostic stream.
So it's protecting the car.
Yes. The system would rather sever all user interaction than allow even a fraction of a second of operation to an unverified device.
Okay, that makes total sense from a liability and safety perspective. It is absolute zero tolerance. There is no guest mode.
None.
But that brings us to the missing keys. Because now that we understand the conflict, this failed cryptographic handshake and the zero tolerance policy, we have to look at the specific tiny missing element that caused this massive lockout.
And this is where it gets a bit absurd.
It really does. The technical remedy detailed in the text is startlingly straightforward, yet entirely uncompromising.
Yeah.
The system requires the manual entry of 8-digit activation codes for both the tablet and the scoop box.
8 digits.
8 digits, that is it.
Yep.
We're talking about a wildly sophisticated diagnostic oscilloscope reading CAN bus microvoltages,
Paired with a high-end cloud-connected tablet.
operating within a global server ecosystem. Millions of lines of code. Incredible processing power.
All of it.
And the ultimate point of failure, the single Achilles heel bringing this entire technological marvel to its absolute knees, is a missing string of 8 numbers.
It's almost funny. But to understand why 8 digits wields so much power, we have to look at how they actually function.
Okay, break that down for us.
Because those 8 digits are not the actual cryptographic key.
Wait, they aren't?
No. A true cryptographic key is a massive string of characters, far too long for a human to memorize or reliably type without making a mistake.
Right. It would be like typing out a whole paragraph of gibberish.
Exactly. The 8-digit code is essentially a hash.
A hash.
Yeah, it's a highly compressed, mathematically derived shorthand representation of the much larger license file that is actually stored on the server.
Oh, I see. So when you type in the 8 digits, you aren't literally typing in the encryption key, you are typing in a pointer.
Precisely a pointer.
You are telling the tablet, hey, take these 8 numbers, send them to the ThinkCar server, and the server will use them to look up my massive, complex, actual cryptographic key in its database.
Exactly. And the text specifies exactly where this must happen.
Where?
In the VCI external modules menu of the Expert 399 tablet.
Okay, VCI, what does that stand for?
Vehicle Communication Interface. This menu acts as the administrative gateway. It is the designated environment where the user must explicitly declare to the software, I possess the manual proof that this external module belongs to my account.
The irony is just staggering to me.
It really is.
We have all this seamless, automatic, cloud sync digital magic, but when the system breaks down, you are essentially back to typing a cheat code into a 1990s video game console just to unlock the next level.
Up, up, down, down, left, right.
Exactly. You have to physically poke at a touchscreen to manually tell the hyper-intelligent system that the box plugged directly into its own USB port is, in fact, allowed to exist.
It perfectly illustrates the ultimate bottleneck of digital rights management, or DRM.
Right, DRM, we usually hear about that with movies or music.
Exactly. It originated in the media industry to prevent the copying of digital music and movies. But as physical tools became computerized, DRM was adapted to manage hardware functionality.
So it jumped from MP3s to wrenches?
Essentially, yes. You can engineer the most advanced sensors on the planet, but access to that physical capability is entirely gated by those fundamentally opaque cryptographic hashes.
Wow.
The hardware is just the potential for work. The 8-digit code is the actual permission to execute that work.
The permission to execute the work. And let's talk about the cost of that permission.
Yeah, let's get into the numbers.
Because this is where the memo pivots from a fascinating technical puzzle into a severe, real-world financial crisis.
A very expensive crisis.
We need to explore the trap of software subscriptions and the financial catch-22 this user, Mr. Evgeny, is caught in.
Poor Mr. Evgeny.
Really. The text reveals that he made a massive initial investment of 14,000 DGN to acquire this system. For context for our listeners, that is roughly 7,000 euros.
That is a serious professional grade capital expenditure. For an independent mechanic or a small diagnostic shop, 7,000 euros is a massive outlay.
It's huge.
It represents a major investment in the future capabilities of the business.
But the cost of entry is only the beginning.
Right.
The text explicitly points out that there is an ongoing annual subscription fee of 2,000 BGN, about 1,000 euros, just to keep the system active and updated.
So we have a high initial capital expenditure coupled with a significant recurring operational expense.
Yeah, 1,000 euros every single year.
And this is where the system's architecture turns from a protective measure for the manufacturer into a devastating trap for the user.
It's a total snare.
The text outlines what it calls the subscription and firmware synchronization issue.
Okay, let's really break that down. Because the memo makes it clear that the missing 8-digit codes aren't just stopping the app from opening, they are breaking the update cycle itself.
Yes. To understand the failure, we really must differentiate between software and firmware.
Right, they aren't the same thing.
Not at all. Software runs on the tablet. It is the application interface, the menus, the buttons.
Okay.
Firmware is the permanent low-level operating instructions programmed directly into the read-only memory of the scope box hardware itself.
So the firmware is inside the box.
Yes, it dictates how the physical circuitry actually behaves. The text states that because those 8-digit activation codes are missing, the server refuses to validate the scope box.
Because it's a foreign device.
Exactly. And because it cannot be validated, Mr. Evgeny is actively blocked from downloading and installing essential firmware updates onto the scope box.
So what does this all mean at the code level? Like the tablet is still connected to the internet, right?
Yes, the tablet is online.
So the tablet software is probably updating itself automatically in the background, getting the latest patches from Thinkcar.
Getting new features, new protocols.
But the scope box is completely cut off.
Precisely. And the consequence of that restriction is what we call a version mismatch.
Version mismatch?
Right. The tablet software evolves to, let's say, version 2.0. But the scope box firmware remains frozen in time at version 1.0.
And how does a version mismatch actually trigger an application crash? Like, why doesn't it just say, hey, please update your device?
Well, at the programming level, software communicates with firmware using very specific memory addresses and command structures.
Okay.
Let's say the updated tablet software sends a command looking for a specific data return at memory address 0x00 on the scope box.
Just a specific location in the brain.
Exactly. But because the scope box is running older firmware, memory address 0x00A might be completely empty. Or it might contain entirely different instruction.
Oh, I see. So the tablet asks a question in French and the scope box answers in Spanish.
It's actually worse than that.
Worse.
Yeah. The tablet asks a question expecting a specific numerical value, and the scope box returns a null pointer.
A null pointer, which means
Essentially, a void. Nothing. And when an application receives a null pointer where it expects critical operational data, it doesn't know what to do. The logic breaks.
it panics.
Yes, this triggers what computer scientists call a fatal exception. The operating system intervenes to protect the system's stability, and it forcefully terminates the application.
Wow.
That is the crash.
Boom. The app just closes. You are back to the home screen.
Yep.
It is a vicious, inescapable cycle. You are paying 2,000 BGN every single year for a subscription service that is supposed to provide you with the latest vehicle data.
Right.
But because you are missing a simple 8-digit code, the system forbids you from applying those updates.
And because you can't update, the memory addresses misalign.
Because the memory address is misaligned, you get a fatal exception.
And because you get a fatal exception, the system violently rejects the hardware at startup.
It creates this paradox where the user is financially compliant. I mean, he is paying the subscription.
But he is cryptographically non-compliant due to a missing string of digits.
It is exactly like paying exorbitant rent on a house, but you are completely locked out of the front door.
That's a great analogy.
And the lock on that door is rusting and degrading because the landlord forbids you from oiling it.
You are paying for the privilege of a degrading, inaccessible asset.
Wait, so you're telling me a 7,000 euro tool is effectively a paperweight just because of 8 numbers? That's insane design.
From a user perspective, yes, it feels utterly broken. It feels like theft.
Totally.
But from an ecosystem security perspective, it is functioning flawlessly.
Functioning flawlessly by doing nothing.
Yes, it is successfully preventing an unverified, potentially out-of-date piece of hardware from interacting with a modern software suite. And this raises an important question, perhaps the most important question in modern technology right now.
What's that?
What does ownership actually mean?
Oh, man. Yeah, because by traditional physical definitions, Mr. Evgeny absolutely owns that scope box. He purchased it. It is his physical property.
He owns the receipt.
Right. He possesses the plastic, the metal, the silicon, the circuitry. It's sitting on his workbench.
But functionally, practically, he is entirely barred from utilizing it.
Yeah. The legal and functional definitions of ownership have completely diverged here.
They really have. He owns the physical vessel, but he is merely licensing the operational capacity.
He owns the body, but he is leasing the soul.
Exactly. And the lease just got suspended over an administrative technicality.
Which brings us to the resolution proposed in the memo, because the text doesn't just outline the problem, right? It issues a very specific ultimatum for what it calls software independence.
Right, they demand a fix.
And the conclusion of the memo is this formal, strict demand directed at the supplier, a company named АВТОДИАГ.
АВТОДИАГ, yeah.
The request is not for a software patch over the air. It is not for a temporary bypass or a digital token sent via email.
No, it's much more tangible than that.
The demand is that АВТОДIAГ must provide the original physical activation cards containing the 8-digit codes for both devices.
Physical cards.
That detail immediately jumped out at me. Why physical cards? We're talking about cloud servers, digital handshakes, over-the-air firmware updates, memory pointers, complex DRM.
Visible text.
Right. Yet the ultimate salvation for this entire digital catastrophe is demanding a piece of printed cardboard.
It is a profound irony, but a necessary one in cryptographic architecture.
How so?
The demand for the original physical cards suggests a need for verifiable, tangible proof of ownership to completely bypass the digital bureaucracy. Think of it as cryptographic cold storage.
Cold storage, like keeping cryptocurrency on a USB drive instead of on an exchange.
Exactly like that. When the digital ecosystem fails, or when a user account gets corrupted, out of sync, or caught in a version mismatch loop like this one,
Right.
the cloud cannot be trusted to verify itself.
Because the cloud is the problem.
Yes. The digital records are essentially contaminated. So the physical card acts as an immutable off-grid anchor of truth.
Wow, off-grid anchor of truth.
It is the genesis block of the user's license. It is the ultimate trump card against a confused server because it represents the physical origin of the digital right.
It is like finding the original ink-signed paper deed to a house when the county's digital registry gets hacked and erases your name.
That is exactly it. You need the physical artifact to prove the digital right.
And once Mr. Evgeny gets these physical cards from АВТОДИАГ, what is the path to resolution? Like, how does he rebuild the house?
Well, the technical goal, as outlined in the memo, is basically a scorched earth approach.
Scorched earth?
It calls for a factory reset, followed by a clean reactivation. Because the current digital handshake is corrupted by the version mismatch, simply typing in the code now might not even be enough.
Oh, because the system is already confused?
Right. They must completely obliterate the current software state.
So they have to tear the digital house down to the absolute studs, wipe the tablet's memory of the corrupted ecosystem rules,
Clear out the bad memory pointers.
and rebuild the handshake from scratch using those Virgin 8-digit codes from the physical card.
Yes. The goal is to establish a pristine connection to the Thinkcar server, authenticate the hardware, download the latest matching firmware for the scope box.
And finally, bring the entire system back into equilibrium.
Exactly. And the text triumphantly refers to this end state as achieving long-term software independence and stability.
I have to stop here because this final sentence feels like a massive contradiction to me.
Independence.
Yeah. How in the world can we call this independence? Let's look at the reality here. Even if АВТОДIAГ sends the physical cards,
Right.
even if Mr. Evgeny does the scorched earth factory reset and types in the 8 digits, he still strictly requires the Thinkcar server to be online to accept that code.
That's the catch.
She still requires the remote club owner to bless the handshake between his tablet and his scope box.
Yep.
If the Thinkcar server goes down for maintenance, or if his internet drops out in his garage, he is right back where he started. That isn't independence. That is just successfully renewing your parole.
Renewing your parole. If we connect this to the bigger picture, your assessment is painfully accurate.
It's so depressing.
It is. In the lexicon of modern connected technology, the definition of independence has been severely downgraded.
Really downgraded.
It no longer means true autonomy from the manufacturer. It no longer means your tool works in a vacuum forever the way a mechanical wrench works in a vacuum.
So what does it even mean anymore?
Independence in this context merely means achieving a stable, uninterrupted lease.
A lease.
It means your specific local hardware is finally aligned with remote server's demands, allowing you to run your own hardware without immediate interference or fatal exceptions.
Okay, so it's a ceasefire, basically.
Yes. It is stability, yes. You can finally diagnose the car in front of you,
No.
but true independence.
Yeah.
That is an illusion maintained by an active internet connection.
An illusion maintained by an 8-digit code.
Exactly.
So to wrap up this incredible deep dive, let's just summarize what we've unpacked from this single, highly specific technical memo.
We've covered a lot of ground.
We really have. We started with a ThinkTool Expert 399 tablet and a scope box, serial number 9TDPB9800298, failing to communicate. We explored how these devices represent the modern, really precarious divide between physical hardware recognition and digital software execution.
And we examined the code level reality of a license pairing conflict.
The failed handshakes.
Right, how a failed cryptographic handshake and mismatched memory pointers can trigger fatal exceptions, completely bricking a 14,000 BGN investment.
We looked at the financial nightmare of paying a 2,000 BGN annual subscription for hardware you are literally locked out of due to firmware mismatches.
The paradox of the modern subscription model.
And finally, we saw how all the advanced sauce ecosystems and complex DRM ultimately bow down to a printed piece of cardboard holding an 8-digit code in cold storage.
It is a stark reminder of the fragile dependencies built into the tools we rely on to do complex work every day.
It really makes you think.
The physical robustness of a tool, like the metal casing, the high-end silicon, it is no longer a guarantee of its utility.
Not at all.
The utility is entirely dependent on the invisible digital tether.
Exactly. So for you listening, the next time you unbox a new piece of technology, whether it is a smart appliance, a diagnostic tool, or, just a new laptop.
Anything, really.
And the very first thing it asks you to do is connect to Wi-Fi to register this device, or connect to a server to verify your account.
Which is always step one.
Always step one. I want you to remember Mr. Evgeny. I want you to remember his 14,000 BGN investment paralyzed on a workbench.
A very expensive paperweight.
And I want you to remember those 8-digit codes acting as the invisible bars, keeping his physical tools locked inside a digital cage.
And, it leaves us with a final, rather unsettling concept to mull over.
Oh, what's that?
Well, we know Mr. Evgeny's immediate solution requires the Thinkcar server to authenticate his physical cards today, right?
Right.
But what happens in 5 years? Or 10?
Oh, man.
If that specific server is decommissioned to save server costs, or if the parent company pivots its business model, or even goes bankrupt.
Which happens all the time in tech.
Exactly. Or if they simply decide they no longer wish to support the legacy authentication protocols of an older device.
Wow.
Does the incredibly capable, physically pristine hardware in your hands instantly, irreparably transform from a professional tool into a useless paperweight?
Just dead forever.
Right. In the modern digital age, do we ever truly own our professional equipment, or are we just eternally renting the right to turn it on?